And welcome back, students. Let's go ahead and jump into our next lesson on programming with inheritance. Let's talk about the right way to define equals. And yes, we're talking about the infamous equals method. So getting started here, previously when we talked about the class object, we said that it has an equals method, and that when you define a class with an equals method, you should override the definition of method equals given in the class object. However, strictly speaking, we did not technically do that. All right, we didn't technically follow that advice. Now, the following is the method equals for our definition of class employee as follows. Public boolean equals employee other employee. On the other hand, the heading for the method equals in class object is as follows. Public boolean equals object other object. Now, you'll notice that the two methods have different parameter types, even though they look very similar. So we have not actually overridden the method, just we've overloaded it. So remember, there's a very clear distinction between that of overriding and that of overloading. The class employee, therefore, technically has both of these methods named equals. In most situations, this is actually not going to matter, all right, even though we have two different equals methods. You have the object one, you have the employee one, for example. It doesn't actually matter. There are a couple situations where, yes, this does apply, where it would matter, but for most scenarios, it won't matter. Now, some library methods assume that you're going to be using your class's definition of equals, which has the following heading the same as the class object. Public boolean equals object other object. So we need to change then the type of the parameter for the equals method in the class employee from that of type employee to that of type object. A first try might produce the following. Public employee equals object other object, employee other employee equals employee other object. Return name.equals other employee name and hire date.equals other employee hire date. However, we need to typecast the parameter other object from type object to type employee. If we omit the typecast and simply proceed with other object, the compiler will give an error message, when it sees the following other object dot name. And this is because the class object does not have an instance variable named name. All right, name belongs only to employee. It does not belong to that of object. So this first try an improved equals method doesn't actually override the definition of equals in the class object and will work well in many cases. However, it still has a shortcoming. Our definition equal now allows an argument that can be any kind of object whatsoever. However, what happens if the method equals is used with an argument that is not an employee? A runtime error will occur when the typecast to employee is executed. So we need to make our definition, therefore, work with any type of object. For example, if the object is not an employee, we simply return false. The calling object is an employee, so if the argument is not an employee, they should not be considered equal. But how can we tell whether the object is or is not of type employee? Well, recall that pretty much every object inherits the method getClass from the class object. The method getClass is marked final within the class object, so it cannot be overridden. Now, final means you can't change it. For any object o.getClass represents returns a representation of the class used to create O. So, for example, of the following executed, if O equals new employee, then o.getClass will return a representation of employee. So we won't really go into the details of this representation because it's beyond the scope of what we really need to know, except to say that two such representations should either be compared with equals equals or with not equals if we want to know whether or not those two representations are the same. Thus, the following code will output same class. If object1.getClass equals object2.getClass, system.out.println, same class. Else, system.out.println, not the same class. Now, if object1 and object2 were created with the same class when they were created using new, then of course the code will output not the same class. So, our final version. So let's take a look at this. All this information that we just talked about with equals. All right, this is our final version of this equals method that we should look at. So here I have public boolean equals object other object. If other object is equal to null, return false. Else if get class does not equal other object.get class, return false. Else, employee other employee equals employee other object, return name.equals other employee.name, and hire date.equals other employee.hire date. And of course, if you don't recall, this pretty much just makes sure that the object is not null. This checks to see if the two objects are not equal to each other. In either of these cases, you'll notice it will return false, which means that that Boolean will say that it's false, because it's just a Boolean, just true or false. Here, this will return that it's true. So, you'll note that with that new definition, we've also taken care of one more possible case. The predefined constant null can be plugged in for a parameter type object. Now, what's interesting to note is that the Java documentation says an equals method should return false when you're comparing an object and the value null. Therefore, that is what we have done in this example code. So if we look back here, we compared other object to null, and we returned false. Now, this is one question you might wonder is, like, do I still need to produce code this way, or can I produce it the way we've been doing with equals methods? The truth of the matter is it's kind of situational, because remember what we said at the very beginning is that for most code using your object comparisons that we've been doing, like employee, other employee, like at the very beginning when we had that code. Let me just go to that slide here. In here, if we had this original method, employee, other employee, that is still okay for most scenarios. So if you are crafting your own class and you don't want to necessarily use object, other object, instead you just want to use a class, again, that is perfectly fine for most scenarios. However, the purpose of this lesson is to help cover and address some of those other scenarios. And we're going to build on this a little bit in the next lesson as well. All right, but I think that's enough for today, folks. So